Basically, this is the summary of the last 3 days in one chart right here. It's really important. You have slope-intercept form, point-slope form, standard form. Sometimes one of the forms will be required, meaning I will say, blah, 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 put your answer in slope-intercept form. Blah, 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 put it in standard form. You need to know the difference between these three forms. You have to. You have to know the difference between those three forms. And then, just to complete everything off, to round everything off, it gives you horizontal lines and vertical lines. But this is the summary of everything from the past 2 sections. Know it. It's in your notes. So, let's talk about the homework. What question did you guys want to see first? 33. Can someone hand me their book? I just don't want to have to load the digital right now. Is 1210. And the slope is what? 1. So it says find an equation of the line. So if it says find an equation, does it say which of the 3 types you need? No. In A it does, but find an equation first. If they give you a point and slope, what form should you use? No. If they give you a point and a slope, what form should they use? Point slope form. I understand that's what you meant, but you need to actually say what you mean. Okay? So what's the general form for point slope form? M times
X minus X.
That has to be automatic, like burned into your memory. So this is going to be y minus what? 10 equals 1 times x minus what? 12. So that's the first part of the question. Find an equation. But then for A it says write the equation in standard form. What is standard form? Hold on. What is standard form first, and then I'll get your question. What is standard form? AX plus BY equals C. So that's the form we want to put it in. It's not there yet. What's your question, Meg? Does that make sense, everybody? So is this in standard form? No. What do we need to do to put it into standard form? We have y minus 10 is equal to x minus 12. Well, y is not isolated. Does y seem isolated to you? No, it doesn't. What's on one side? And, so what should we do? We're isolating x and y, but we're putting them together. So can someone tell me what I should do mathematically to this? Add 10. Let's add 10. I like that. So we end up with y equals x minus what? 2. Is that in standard form?
That's in
Slope-intercept form, but that's not what we want. We want standard form. So what do we do to that to put it in standard form? Nope, not add 2. Subtract x from both sides. If we subtract x from both sides, you end up with y minus x is equal to negative 2. This is in what? Standard form. What was the form right above it? Slope-intercept form. So this would be A. B says write the equation in slope-intercept. Oh, look, we already had it right there. We found it along the way. So we've written it in 3 forms. This is what form? Point slope. Along the way, we found slope-intercept, and then we finished with standard form. It's a very common question for me to ask you theoretically. Write it in all 3 forms. Yes, Noah? Asking you, find an equation. Does it tell you what form it should be in? No. Okay, if the slope is 0, what type of line is that?
That is a
What type of line?
horizontal.
Horizontal line. What form does horizontal lines have? Is it y equals or x equals? Y equals something, right? In this case, what's the y equal? Y equals 5. Done. All done. That's it. 48. So 48 is very similar. It says negative 2, 8, and the slope is what? What type of line is that?
No.
It is a line. What type of line is that? Vertical. Thank you. Vertical lines have an equation what?
So it's just x equals negative 2.
X equals A, so this is x equals negative 2. Done. That's it.
Those were a lot easier than
Yeah. Summarize this. We had 900 minutes for $60 a month, plus a one-time activation fee of $36 once. That's the first sentence. A Nokia 650 cell phone is included at no additional, so plus phone. Nice. Okay. Let x represent the number of months of service and y represent the cost. So x is time in what? Months. And y is the cost. If you sign a 1-year contract, how much will this cell phone plan cost? How much will this cell phone plan cost? So it's $60 a month. So if it's 2 months, how much is just the monthly going to cost you? 60 times 2, 120, exactly. But there's a one-time fee. What is it?
Plus 36.
So, well, the cost is plus 36. So it's $60 times the number of months plus what?
36.
36. So the cost is equal to that.
I got
It's asking you for what does a year cost. So what do you have to plug in for x?
12.
X equals 12. So y is going to equal 60 times 12 plus 36. So that's going to be $1,200 plus 36 is equal to $1,236. So after 1 year. So they wanted you to build an equation and plug in 12. That's what they wanted you to do. The rest of class. So what I wanted to go over right here are a few things that we didn't get to from the last section, some questions. It says a local gasoline station is selling 89 octane gas for $3.20 per gallon. Write an equation that describes the cost Y to buy X gallons of gas. Can anybody tell me what this equation is going to be? It's about as straightforward as it gets. Anybody? The cost is going to be what?
Y.
So what do you put in for M?
The cost.
Which is?
320.
So it's 320 times X. Plus what?
989.
No, 89, that's just the label. That's just the label.
I
This line, this is the cost of gas. If you don't buy any gas, what should the cost be?
0.
So should this go through the origin?
Yes.
Yes. Does it go through the origin? Yeah. What about this one? A car wash at this gas station costs an additional $3. Write an equation that defines the cost of gas and a car wash. What's the only thing you need to change about this? Plus 3. It's going to be y equals 3.2 x plus 3. That's it. The 3 is a one-time cost. It's like those setup fees we just talked about.
Would that be y equals mx plus b?
And b would be 3 in this case. What's the b in this case?
0.
Exactly. Sometimes, though, real-life data, does real-life data perfectly fit a line?
No.
Sometimes there is a general linear relationship. There is a linear relationship, but it's not perfect. Real-life data is rarely perfect. If you ever get real-life data that is perfect, what does that probably mean about the data? You should be, like, maybe a little skeptical. Like sometimes if you had just 2 points, oh sure, any 2 points define a line. But if you got 10 random points that you generated through data collection and they're perfect, how many people have taken chemistry before? Or physics or done a lab? Do you ever get 10 points on a line?
Nope.
You really don't. It's all over the place. Sometimes the relationship isn't linear. But in this class, we're not talking about like quadratics of best fit. We're just talking about lines of best fit. So what's the point? If I had a data here, it says average annual tuition. So here's the year, here's the cost in dollars, year cost in dollars, and I graph it. What's the point of graphing the data? Why would we do that?
To see where it like goes up.
Exactly, to see where it's going. Maybe to infer something, to make a prediction. So if I wanted this, if I wanted to analyze this, I might want to come up with a relationship, Sadea, between all of these points. How would I come up with a relationship between all of these points? What might I place on here?
A line.
A line. We might place a line. And anybody know what that line is going to be called? A trend line or line of? Yeah. I like calling them line of best fit. So if we drew this line, it could help us make predictions out there, for example. But if we draw that line, what might we need of that line? The what of that line? The
Slope.
So we could generate which is called an equation. You got it. We'd love to generate an equation. How many pieces of information do you need to write the equation of a line? 2. 2 points or a point and a slope, right? Point and slope is great. So in this case, when you're choosing points, that's what you're going to do here. Should you choose points that are really close together or generally far apart? Why? Why do we want to pick points that are generally further apart, Gabby?
It's like an average.
It's more of an average, exactly. The closer points are together, the more error there could be. It's easier for there to be error. So, for example, do you have to pick points? Do you have to pick these points? Do you have to pick the blue points? No, you need to pick points on the line because you want the equation of the line. Do we happen to have one point that's on it? Is that always going to happen? No. So we could pick this point, and maybe if we're going to pick another point, we want to pick a point you can estimate well. So let's pick this point right here. What's the x-coordinate look like for this one?
5.
It looks like it's 5, and the y-coordinate's, let's say, halfway in between, so 25, 50. And let's pick another point. Let's say on 2. Yeah. It's kind of in the middle. Maybe we can go a little further apart. So maybe let's go right here. That's at 1. What's that one going to be? 1 comma what? 21. Let's do 50 just to make, let's do 50 just because it's going to make that math easier. Now, if we want to find the line of best fit, we need 2 pieces of information. We do have 2 points, but we're going to use those 2 points to get what? The slope. It's the rise over the run. So 2550 minus what?
2150.
2150 over 5 minus, what's that going to be? 400 over, oh, did it work out kind of nicely? Does it always work out that nicely?
No.
Might you end up with like 117 over 12 or some crazy fraction?
Yeah.
Is that a number? Don't discriminate. Is that still a number that you could get? So if that's the slope, we now have a slope and 2 points. Is that more information than we technically need? Yeah. What form of the line do you want to use to write the equation? Slope and a point. So we're going to use what? Does it matter which point we use? Which point do you want to use?
The smaller.
Yeah, sure. Let's make the smaller one. Generally speaking, if you have a choice, smaller numbers, doesn't matter really, not really. So what's the equation going to be if we use these two pieces of information? Raise your hand and someone tell me. Y minus what? Y minus what? 2150 equals, what's the slope? 100 times x minus what?
1.
Done. If I don't specify the form, can you stop there? Yes. What form is that in? Point slope. You're done. There's your equation. Can you translate it into like slope intercept if you wanted to? Sure. But I'm not asking you to do that right now. Hannah. Changes except for one thing. Can someone tell me what's the new thing that's written up there? Yeah. These inequalities. So what's the only thing that changed?
The equal sign to the inequality.
Exactly. Can you graph lines if I gave you the equation of a line? Are you like pretty confident in that 5 is like you could do it in your sleep 0? Where are you right now? Could you graph it? You pretty confident graphing lines?
Yeah.
Inequalities, exactly the same except for 2 things. One, the line itself could be solid or dotted, and you get to shade one side. That's it. You graph the line, decide if it's solid or dotted, and then shade one side or the other. That's it. Nothing else changes. So the first thing you do, you graph the line. The second thing you do is decide, is it dotted or solid? And the third thing you decide is, where do I shade? That's it. Nothing much changes at all. So for example, you might get something that looks like this, where the pink or the blue is your solution set. It's just saying there's 2 sides to that line. That's it. So let's say I asked you this right here. If I asked you to graph this, what did I say the first step is? What's the first step?
Graph the line.
Graph the line. So graph first 3x plus 2y is equal to 6. Can someone tell me what the easiest way you can think of in your head to graph that is? What do you think the easiest thing to do is? Noah? No? You could put it into a different equation, but what form is this in? Whenever you see something in standard form, you should think to yourself, intercepts. Intercepts are awesome because here's the thing. If you have 2 points, what do you do with those 2 points? Connect them and you're done. Intercepts are nice because you're plugging in what number? The x-intercept is when y is 0. The y-intercept is when x is 0. So if x is 0, what's y on this one? 3. When y is 0, what's x? 2. So we have 2 points. Hey, can we graph those 2 points pretty easily? We go over to 2, let's say, right here. Here's 2, and we go up 2. Let's call that 3 right there. It's not really to scale, but now we did those 2 points. Now the question is this a solid or a dotted line?
Solid.
Who thinks it's dotted? Who thinks it's solid? It's equal to, so it's solid. You see how that's solid right there? It's equal to, therefore it is solid. If that wasn't, it was strictly greater than, it would be what? One thing that's nice, I'm going to do this here. You have an erase tool. You can start erasing pieces. Remember that you can do that. But in this case, do you have to erase anything? No. What's the last step? Shade. To shade, you need to test a point. You can test any point you want. What point, if you can test any point you want, is the easiest point to plug in? 0, 0. Your question you're answering is, does that point make the inequality true? 0, 0. 0 plus 0, is that greater than 6? 0, 0 is right here, so is this side part that you shade? It isn't, so what part do you shade? The other part. So you do that, and then you go boom, 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 boom. There's your shading. Oh, by the way, when you shade, please don't go berserk. I can guarantee some of you are going to sit there. Like, don't do that, please.
Always like stood for 1.
No, it does not always stand for 1. It stands for any number you want. So x minus 3y equals 4. Start there. When x is 0, you need to find out what y is, and when y is 0, you have to find out what x is. So when x is 0, you have to fill in those blanks. Do that first. Noah, what's the y? So when x is 0, what's y?
Y equals 4/3.
You sure it's 4/3? It's negative 4/3. And when y is 0, what's x? 4. So what do you do with those 2 points? Plot them. You just plot those 2 points. So do x is like, okay, 0, negative 4/3. Where's that? Oh, it's down, let's say, right here. 0, negative 4/3. 4, 0 is going to be over to the right a bit. Let's call it right there. What do you do with those 2 points?
Draw a line.
You draw the line in between them. So you draw this line right here. And once you draw that line, what's the next thing you have to decide, everybody?
Which side is shaded?
Nope.
Or whether it's
Dotted. Solid or dotted. Solid or dotted. That's right. So, is it solid or dotted? It is dotted because is there an equal sign in it? Nope. So you can do this and go boom, boom, get rid of these pieces. And look, it's suddenly dotted. It's kind of cool. Nice. Now, can you use 0, 0?
Yes.
Yeah, you look at the original equation up here. Look at the original equation. Look at the original equation and say, when you plug in 0, is it true? Is 0 minus 3 times 0, is that question mark less than 4? Yes, it is. So which side do we shade, above or below? Above or below? Above. There it is, right there. All done. We are not done yet. Do not pack up. Do not pack up. Do not pack up. So we will stop here. You should be fine to do this.